Welcome to this presentation on Group 2 elements. Group 2 elements are known as the alkaline earth metals. They are found in the second column of the periodic table and include beryllium, magnesium, calcium, strontium, barium and radium. Introduction to Group 2 and Chemistry Specification Focus. Group 2 of the periodic table is known as the alkaline earth metals and includes beryllium, magnesium, calcium, strontium and barium. Group 2 elements all have 2 electrons in their outer shell, giving them an outer electronic configuration of Ns². This shared configuration is the foundation for their similar chemistry, particularly their tendency to form +2 ions by losing 2 outer electrons. Atomic radius and first ionization energy trends. Atomic radius increases down the group because each successive element has an additional electron shell. This extra shell increases the distance between the positively charged nucleus and the outermost electrons. At the same time, increased electron shielding from inner shells reduces the effective nuclear attraction felt by the outer electrons. First ionization energy, defined as the energy required to remove 1 mole of electrons from 1 mole of gaseous atoms, generally decreases down the group. Although nuclear charge increases, the effect of increased shielding and atomic radius outweighs this, making it easier to remove an outer electron. Reactivity trends and reducing power. Reactivity refers to how readily an element loses electrons in chemical reactions. For Group 2 metals, reactivity is closely linked to first ionization energy and atomic size. As ionization energy decreases down the group, metals such as calcium, strontium, and barium lose their outer electrons more easily, making them stronger reducing agents. In redox terms, Group 2 metals are oxidized by losing 2 electrons to form M² ions. Reactions with oxygen, water, and acids. When heated in oxygen, Group 2 metals form metal oxides with the general formula MO. For example, magnesium burns with a bright white flame to form magnesium oxide. These oxides are basic and react with acids to form salts and water. Reactions with water demonstrate increasing reactivity down the group. Magnesium reacts very slowly with cold water but more readily with steam to form magnesium oxide and hydrogen. Calcium, strontium, and barium react with cold water to produce the metal hydroxide and hydrogen gas, with increasing vigor down the group. Solubility of hydroxides and sulfates. The solubility of Group 2 hydroxides increases down the group. Magnesium hydroxide is only sparingly soluble, while barium hydroxide is much more soluble. This trend can be explained by considering the balance between lattice enthalpy and hydration enthalpy. As the metal ion becomes larger down the group, lattice enthalpy decreases more significantly than hydration enthalpy, favoring dissolution. In contrast, the solubility of Group 2 sulfates decreases down the group. Magnesium sulfate is soluble, whereas barium sulfate is virtually insoluble and is used medically in barium meals. Thermal decomposition and flame tests. The thermal stability of Group 2 carbonates and nitrates increases down the group. On heating, carbonates decompose to form the metal oxide and carbon dioxide, while nitrates form the oxide, nitrogen dioxide, and oxygen. This increased stability is explained by decreasing polarizing power of the larger M² ions, which distort the carbonate or nitrate ion less effectively. Flame tests provide a simple analytical method to identify certain Group 2 ions. Calcium produces a brick-red flame, strontium a crimson flame, and barium an apple-green flame. These colors arise from electronic transitions within metal ions. To summarize, Group 2 metals have 2 outer electrons, form 2+ ions, and become more reactive down the group. Understanding these trends helps explain their chemical behavior. Thank you for watching.